If you haven't already finished the do now, pause the video now and finish the do now. Okay, looking at the do now, we want to go ahead and complete this table after finding the constant of proportionality. So in order to complete the table, we do have to find the constant of proportionality. When I think about miles per gallon, the number of gallons of gas that I have can determine how many miles that I can drive. So I've labeled them x and y. In order to find my constant of proportionality, I need y over x. And y over x is going to be 150 over 10, which is 15 miles per gallon. So once I have the 15 miles per gallon, I can set up my equation. Y is equal to 15x. If I'm looking up here I'm given a y value of 80. So I can plug that into my equation. Go ahead and divide by 15. And this is not going to come out to be a whole number, because I know 75 would be a whole number. 75 would be 5 times, so I'm actually going to get 80 over 15. I'm going to simplify. Let's see, 80 over 15 over 5 over 5 is going to give me 16 over 3. So 16 over 3 is equal to x. If we want to simplify that, that's 5 and 1/3 gallons of gas. On the other hand, when we've got this one over here, we've got an x value that we can plug into our equation. So using our same equation, same proportional relationship, y equals 15x, y is equal to 15 times 4.5. So when we multiply that out, 14.5, 15 times 4.5, do some quick math here. One decimal place, so I'm going to get 67.5 miles. Should be able to go 67.5 miles on 4.5 gallons of gas. And that should make sense to us because this is less than the 5 1/3 gallons that we had up here. So we should be able to go less than 80 miles. And that makes about sense. All right, so let's look on over at our classwork for today. All right, today's aim is a follow-up on a lesson that we started on Thursday, but we got stuck somewhere in the middle. So we're actually coming back to it today. We're going to do the full lesson. We're not going to be stuck in some of the places that we were before. So our aim today, Kipsters will be able to use proportional relationships and equivalent ratios to complete I think it was over here. So to complete tables with total columns. So there's really two parts of this lesson today. One is really just using the information that we learned from yesterday's lesson and that we just practiced on the do now. And the other part of it is going to be figuring out, what is this third column all about? And how can I use that third column? And how can I work with that third column to find out more information? So we're looking at a scenario here where we have, we talked about this situation before, where we have hikers and backpacks, and we're trying to figure out what the total weight is based on the hiker's backpacks. So when we think about this, we start by really just saying, all right, this is our x and this is our y. These are the two things that have a proportional relationship. The hiker's backpack, or the hiker's weight, is determining how much backpack weight that we're giving them. So in this particular case, we're going to go ahead and find the y over the x, the constant of proportionality. So it's our y over our x is 20 over 160. Now I can see when I go ahead and divide this out that this is definitely going to be less than a whole. So I could turn this into a decimal if I really wanted to, but for this case it's actually easier to use this equation if I just simplify this fraction. So I'm going to start by dividing by 10 over 10. That knocks off those extra zeros, gives me 2 over 16. Then I notice I can divide by 2 over 2, and that gives me 1/8. So the equation that I can use for the relationship between the hiker's backpack, or the hiker's weight, and their backpack weight is that y, the backpack weight, is equal to 1/8 of the hiker's weight, x. So for now, I can ignore the totals column, and I can at least find out the information here. So I've got a couple of x values to plug in here. So I'll go ahead and set equations up for those. I will do it in red here. So y is equal to 1/8 x. In this case, I'm plugging in 132. 1/8 times 132. And we can see here that really when we're multiplying by 1/8, it's the same thing as dividing by 8. So 132 divided by 8, and do that work over here, 132 divided by 8. This goes in one time, the remainder 5, 2. Goes into 52 6 times, it's 48.0. So 16.5. So y is equal to 16.5 pounds. So that hiker will have 16.5 pounds. So y equals 1/8. Now for 64. And again, this is like dividing by 8, and so this one's pretty easy. That's going to be 8 pounds. Alright, so looking over here, we actually see that this one should be pretty easy. We have a y value here of 8, but we actually already have that pair set up on our chart, so we actually don't have to do any work here. This one's just going to be 64. Now over here on this last one, we have a y value of 15. So when I use my equation, I'm going to have to be plugging in for the y this time. So y equals 1/8 x, and my y is 15 times x. So I'm dividing by 1/8, but really we know that's the same thing as multiplying by the reciprocal. So I'm going to get 15 times 1 over 8, the reciprocal would be 8 over 1, is equal to x. So 15 times 8 would be 120. So that's pretty simple when we look at that, filling in those two columns. Now total weight, the way that we would find the total weight is to go ahead and add up the backpack weight plus the hiker's weight. So 160 is 180. 120 and 115, that'd be 135. 132 plus 16.5 would be 148.5. 64 plus 8 would be 72. Again, 72. And 120 plus 15 would be 135. So we can see those total weights all add up here. And kind of the question that we want to ask ourselves is, is all of this proportional, because we have to do something over here to figure out how to get these total weights. We've got total weights over here, how to figure out the rest of it. So one way we could think about that is, well, is there a proportional relationship between hiker's weight and total weight? And we really want to think about that in terms of, can we think globally whenever we have a situation like this where maybe there's multiple things along the line here? Is it all still very proportional? So let's go ahead and look at just 3 of the lines. I'm going to pick the lines that appear to be easiest to work with. This one, and this one. And I'm going to go ahead and just calculate the relationship of the constant of proportionality for the total weight and the hiker's weight. So in order to calculate that constant of proportionality, I'm just going to calculate total weight over hiker's weight. So for this first one, that's going to be the total weight is 180 over 160. And again, this one, it's not going to come out as an even number, so I'm just going to go ahead and simplify the fraction. Divide by 20 over 20. That's going to give me 9/8. Alright, so for the second row, I'm going to do the same thing. It's going to be, the total weight is 135 over 120. This appears to be divisible by 5. Five over 5, and that's going to give me 17 over, sorry, not 17, let's try that again, 27 over 24, and these are both still divisible by 3, so when I simplify that further, I'm going to get 9/8. So it looks like we're going to have the same constant proportionality. We're going to check that with that last one down here, 64 over 8. So the total weight was 72 over the hiker's weight, which was 64. And these are both divisible by 8 to give me 9/8. So really what this tells us is that our hiker's weight could be, we could use the relationship between the hiker's weight and the total weight to kind of give us an idea of using that. We could set up an equation where we had the total weight, which we use kind of as our y up here. Total weight is equal to 9/8 of the hiker's weight. And so we could come down and we could use that to find the hiker's weight using that equation. We could plug in the total weight is 225 and solve for the hiker's weight. We want to see if we can do the same thing with the backpack weight, so I'm going to do the same thing. I'm going to calculate my total weight over my backpack weight. We're going to see if this would be proportional. So my backpack weight here is 20 to my total weight of 18, or 180. I can divide by 20 over 20, and that's going to give me 9/1. So we can see that the total weight is going to be 9 times that of the backpack weight. And we just want to check to see if that's true across the board. So my total weight of 135, backpack weight of 15, divided by 15 over 15, and then again I'm going to get 9/1. Same thing down here with this last one. One is 72 over 8. Divide both of these by 8/8. I'm going to get 9/1. So again, we can see we treated this as if it were y over x. So we could say that the total weight is equal to 9 times the backpack weight. So the question is, how can we find these last two rows? One, we could use these relationships up here to go ahead and find or use the equations. We can plug in these total weights to find the hiker's weight and the backpack weight. Or there's another way that we can really think about any of these proportional relationships, and that's by thinking about equivalent ratios. So we know that the ratio of the hiker's weight to the backpack weight is always going to be the same. And so when we simplified that ratio, we saw that it was a 1:8 ratio. That was our constant of proportionality from hiker's weight to backpack weight. So this is our backpack weight to our hiker's weight. So if I'm thinking about this, I can really just start going through and saying, hey, that ratio has to be the same. These two things are proportional. So what are my possibilities here? So to keep that ratio the same, I could say, oh, it's times 2 over 2. And so one possibility would be 2 over 16. And so we're trying to get a ratio where those things are going to add up. The total, the numerator and denominator, would add up to 225. So maybe I'm just going to guess and check here. I want something to be in the range of 225. I can see that definitely looking at what I have here. I already can see that it's definitely going to have to be a backpack weight that is bigger than 20. And so maybe I'll try 25. I'm going to have 1 over 8, and I'm going to try 25 over 25. So top times top, that gives me 25 pounds for the backpack weight. And 8 times 25 is actually 200. And I can see that if I add these two things together, this will make sense. That my hiker's weight, 200 for my hiker's weight, and 25 for my backpack weight, and that would work out for us. So that's one way. And then I can also try and do the same thing for the 90. If I'm looking at the 90, I know that it's going to be greater than a backpack weight of 8, but less than a backpack weight of 15. So maybe I'm going to try something in the middle there. I can try 12. 1 over 8 times 12 over 12 is going to give me 12 over 96. I can see that would add up to 108, so I definitely ended up with something that was too big there. So I'm going to go down to 10, and that's going to give me 10 over 80. And those do add up to 90, so I can plug those in. So we can see that there's this idea that we can use equations, but we can also use this idea of equivalent ratios if we know the constant of proportionality to kind of help guide us along the way. Looking at our partner work time, I want to get you guys started a little bit here before you kind of finish these two problems on your own. So looking at this first one, this one's a little bit different than what we've seen before. We can see that there are lots of different ingredients and lots of different ratios that we could be writing here. The first thing asks us for the total amount of toppings on the pizza. So if we add all of these things together, I'm going to go ahead and save you the time. Go ahead and tell you that this all adds up to exactly 1 cup. So when we look at this, the table down here is showing us 3 different orders, and we don't know how many pizzas there were in each order, but we do know some of the amount of the ingredients that were used in each order. So when we think about this particular problem, it may be easiest because there are so many different ratios that could be going on to come up with one ratio that's most important. And if we're given the ingredients per pizza, we can use that ratio as long as we can figure out how many per pizza. So looking at this, if I look at my sausage, I can see that the ratio that I'm going to have there is it's 1/4 of a cup of sausage for 1 pizza. That way we can come up with the ratios that we can use for all of these. So with the pepperoni, we can see that it's going to be 1/3 per one pizza. The bacon is 1/6 per one pizza. The ham, the beef, and the total, we should have 1 total cup of ingredients for one pizza. So coming down here, we need to start figuring out, well, this is really easy. If I know how many pizzas there are, all I really need to do is multiply by the number of pizzas. But at this point, we aren't exactly given that information about how many pizzas there are. So we're going to have to use our brains here and kind of the idea of these equivalence ratios to help us sort this out. So I can see that there is 1 cup of sausage. So if I look at my ratio for sausage to pizza, I have 1/4 cup of sausage for one pizza. And I know that there is 1 cup of sausage in this order. And I want to know how many pizzas. So the question is, what did I have to multiply top and bottom by here in order to get this new ratio? 1/4 times what is 1? Well, here we know that's going to be 4. So this is going to tell me 1 times 4. This is 4 pizzas. Which means that if I start looking down the line, all I need to do to figure out each of these toppings in order 1 is to go ahead and multiply each of the sets of ingredients times 4. So for the pepperoni, for order 1, I have 1/3 times 4. 1/3 times 4, and that's going to give me 4/3. For the bacon, it is 1/6 times 4. That's going to give me 4/6, which actually simplifies to 2/3. For the beef, looks like we should have 1/8 of a cup of beef times 4. It's going to give me 4/8, which we know is 1/2. And for the total cups, we know that it's 1 cup for one pizza, so that means we should have a total of 4 cups. So we want to do the same thing for the other 2 orders, and I'll get you started off on thinking about how many pizzas there are for this next one. We have 1 cup of bacon. So going back to our bacon ratio per pizza, we have 1/6 of a cup of bacon for one pizza. And our equivalent ratio tells us that we now have 1 cup, and I want to know how many pizzas. So I'm thinking about, what do I need to multiply both my top and bottom here by? And that's going to tell me how many pizzas. So go ahead and finish this up, jump through this order, and then over here, this is very much like the first problem that we did with the backpacks. You'll need to find your constant of proportionality, write your equation, and then you can use that constant of proportionality to kind of help guide you using equivalent ratios to find these missing pieces. If you have questions, feel free to jump into the lesson and ask those questions as they come up. Go ahead and pause the video now, and I will go ahead and finish the solutions here so you can check it out. Alright, coming back to this, if we want to finish this up here, we want to see that we're multiplying by 6/6 here. So that's telling me this is 6 pizzas, which means I'm multiplying everything times 6. The sausage, 1/4 times 6 would be 6/4. Simplifies to 3/2. The pepperoni would be 6 times 1/3, which would be 6/3, which is 2 cups. Coming down to the ham is 1/8 times 6. That would be 6 over 8, which is 3/4. And the beef is the same, 3/4. And the total, since there's 1 cup to 1 pizza, is going to be 6. For order number 3, when we look over here at order number 3, we are given that there are 3 cups of pepperoni. So I'm going to come to my relationship on the pepperoni. And I know that there is 1/3 per pizza on the pepperoni, and I need to get it to 3 cups. So I know that it'll take 1/3, 1/3, and 1/3 to get to 1 cup. So that's 3, then times 3 more. There's going to be times 9 over 9, which tells me that this is going to be 9 pizzas. Again, jumping through each of those multiplications, this is going to give me 9 times 1/4. That's going to be 9/4. The pepperoni already taken care of. The bacon, 9 times 1/6. That's going to be 3/2. The ham is in 8ths. So that's going to be 9/8. Which actually we know it's the same as that. And that's going to give us me a total of 9 cups of ingredients. Coming over here to this one, doing our y over our x, so our x over our y. This is going to be 3/4 divided by 3. And so when I divide that by 3, that's going to be like multiplying. This is going to give me 1/4. So y is equal to 1/4 x. And I can go ahead and start plugging in some values here. So this is a y of 1/4. 1/4 is equal to 1/4 x. Well, this one's going to be really easy. Dividing by 1/4, dividing by 1/4. 1/4 divided by 1/4 is going to give me 1. Looking for this value, I'm going to plug in 2/3 for my x. So y equals 1/4 times x. In this case, our x is 2/3. And so that's going to give me 2/12, which is 1/6. Alright, so for these other ones, I'm going to need to use that ratio. Actually, let's go ahead and add up these totals that we have over here. This is going to be 3 3/4, 1 1/4, and 5/6. And now for these other ones, I need that equivalent ratio. I'm going to go back to that idea of equivalent ratios. I know I've got a 1/4 ratio, and I need to make sure that that adds up to 5. In this case, that makes it actually really easy here. We see that our cheese, which is our y here, should be 1 and 4. That's going to keep my ratio. And now I need it to add up to 10. And so this actually is also pretty easy. We recognize here that if we multiply by 2 over 2, that's going to give me 2 over 8, which will add up to my 10. Alternatively, you could have written equations for the relationships between the cups of cheese and the pan size, and the noodles and the pan size, but that definitely is more time consuming in this particular case. Alright, please move on to your independent work. You have one problem to work on.